Hello everybody, Namaskar. Now we are at the 8th lecture. In the next half an hour or so, we will discuss about various issues related to handling and transportation of fruits and vegetables. The concept which we will cover here is handling of different fruits and vegetables at different stages, transportation and its various models, reefer vans or refrigerated vehicles, temperature control and air circulation systems in vehicles, and loading consideration and patterns with a view to take care so that there is no damage during the transportation and handling of the produce. What do you mean by handling of fruits and vegetables? Obviously, taking the commodity from one place to other place, because these fruits and vegetables, they are very vulnerable commodities. So, improper handling may cause deterioration, and also it is one of the major cause for the post harvest losses. So, careful and proper handling of the produce at each and every stage is necessary or essential, and careful handling protects the quality as well as enhances the shelf life of the produce. So, what are the different stages during the handling of the commodity, like, and where do we need to take proper care? That is at the time of harvest at the field, at the time of loading and unloading, at the time of transportation during the transport, at wholesale market, at retail market, and ultimately at the consumer end. Okay. So, what should be done in the as far as handling in the field is concerned? Avoid use of dirty containers which can increase the load of microorganisms. Handle the produce gently to avoid mechanical injuries which could result in defects. Harvest the produce at its optimum maturity. Proper handling in the primary operations such as washing, cleaning, dressing, sorting, grading and packaging, etc. must be ensured. As far as the handling during loading and unloading, see that loading and unloading may be done at different places, like at the pack house, at the field, at the retail market, or at the wholesale market. So, while loading and unloading, packs should not be thrown, the packets should be handled gently. One should not use hooks, that is, hooks should be avoided for pricking the bags and crates. Torn bags and broken crates should not be used. Different grade packages should be kept separately. They should be handled gently during loading and unloading. Then during the transportation, that is produce leaving the field or farm or the market or storage, it should arrive in the same condition. That is important. Every care should be taken so that the produce arrives in the field or in the farm or in the marketplace in the condition, same condition in which it started from the field. So, what are the preventive measures that should be taken during transportation? That safe driving, that is at the field as well as rough farm tracks, the vehicle should be driven safely, and it avoids compression damage to the produce, and therefore, it helps maintaining the quality. Otherwise, if there is unsafe driving and jumps, etc., there may be compression damage may be there to the produce, and it will lose its quality and it will spoil in the vehicle itself. So, careful loading of the produce in the container, it avoids shifting or collapse of the load. The covering bulk load or open top containers, etc., that is, they should be properly covered, and this is it prevent excessive dehydration in hot weather and protect the produce in wet weather. Critical supervision at all stages of the transportation must be ensured. This is very important because it minimizes the chances, any chance of physical injury to the produce. While handling in the wholesale market, it may so happen if it is properly not handled, the produce may get damaged. That is, while in unloading, if it is not handled gently, during storage it may get damaged. So, store should be cool, clean and shaded place, and loading for the retail dispatch also. From the wholesale market, when the material that you are unloading in the wholesale market, and then from there it is being again loaded and sent to the retail dispatch, there also it should be handled properly, otherwise there may be chances for damage. Or in the retail market, that is the commodities, care should be taken that only required quantity should be kept at display and other remaining materials should be kept in proper place. Periodic water spray on leafy vegetables maintain quality for longer period, and you might have observed many times even in our local market, if you go to the vegetable shop, the green beans or in the green vegetables etc., they sprinkle water. So, this helps in keeping the commodity fresh. So, the produce which is not kept in display should be stored in controlled environment, and ultimately, as a matter of fact, that is a thumb rule, that avoid any type of mishandling of the produce. Handling at the consumer end, that is obviously the consumer is the last person to handle the produce. So, at low temperature, if the produce is stored in a particular manner, it can be in a proper manner, it can be kept fresh for longer period of time. That is the green leafy vegetables. I am talking about the handling in the household. So, the green leafy vegetable, they should be wrapped in wet cloth and then stored. Beans, brinjals, cauliflowers, cabbage, radish, carrot, chili, capsicum and rooty vegetables, they should be kept in polythene bags, or before keeping in the bag, it must be ensured that extra moisture, if there is any on the surface of this produce, it should be removed. Fruits like apple, guava, onion, garlic etc., they should not be kept together with the other vegetables due to their typical flavor and aroma, because it may so happen if that strong flavors vegetables or fruits are kept together with other mild flavor vegetables or fruit, so there may be transfer of flavor from one vegetable to the other, one fruit to the other. So, that should be avoided, that is these type of things. So, this is, if these cares are taken while handling at the consumer end, you will get a good quality. Then now let us discuss about transportation. Fruits and vegetables are transported and thereby handled several times before they reach to the point of the sale. So, proper selection, packaging, handling and maintenance of optimum temperature during all stages, as I told you earlier also, prevents physical damage and retards natural deterioration process. Quality losses of the produce are minimized during journey if the transport vehicles are well designed and properly constructed, if they are properly loaded with well pre-cooled produce. Pre-cooling methods and advantages of pre-cooling we discussed in the last lecture, and the vehicle should be maintained at optimum temperature. The commodity also, when it is loaded or inside during the transportation, the commodity should be maintained at the proper temperature, optimum temperature etc. Nowadays, we are living in the information technology era. Consumers are well aware about their health and what they should eat, what they should not eat, that the consumers are very much quality conscious, and this has increased the demand of fresh produce of good physical quality appearance and the produce which is safe to eat. So, quality loss is the result of improper handling, storage and transportation. Okay. During transportation, if the temperature management is poor, as I told you, if there is a lack of a progressive transport system, if there is a lack of refrigerated transport, or if there is a improper loading and unloading, the practices for loading and unloading are not proper, and the poor infrastructure. So these are the some issues in the transportation which must be taken care of. So what are the recommendations? That is, create awareness on proper transport system management. As far as possible, use horticultural value chain vision. Provide financial incentives both in the terms of front and back ends. Encourage investments. Provide laws that give investors the assurance of security. So these are some of the recommendations which should be implemented to deal with the issues related in the transportation, and this will help in maintaining the quality. Different modes of transportation, maybe rail, road, marine, air. In this slide I have made a comparison of these modes. So this road is generally used in intracontinental shipment. The produce which has a short shelf life is shipped or transported by road. The cost of road transportation, we are talking about road transportation, cost is moderate, and the types of vehicle that are recommended for the road transportation include refrigerated trailer vans, intermodal containers, etc. Rail transport is also generally used for intracontinental shipment. It is used for the commodities because sometimes when there is a comparatively long distance shipment is needed. So the commodities would have medium shelf life or more than little longer shelf life. Okay. So and the cost of the transportation here is moderate to low, and the mode may be ice refrigerated rail car, mechanically refrigerated rail car, refrigerated semi-trailer or flat car, or intermodal containers. So these are the different containers or wagons which are used by the railway to transport these fruits and vegetables. Marine transportation can also be used for the intercontinental, both marine and air shipments. Air transport can be used for intercontinental shipments, and in the marine shipment can be used, that is the commodities which have long shelf life comparatively for 3-4 months, etc. So they can be used shipped by the sea. It is considered to be one of the most economical mode of transportation. Conventional refrigerated ships are used, or even container ships can also be used. But air shipment, particularly when it is very high value produce, it has very short shelf life because it is expensive. So this high value producer which has short shelf life, where you want to ship it or transport it in very small minimum duration, less duration, it should be used. Especially modified wide bodied jets or general cargo, etc. can be used for this purpose. Now let us discuss about reefer vans or refrigerated vehicles. So the schematic diagram of a light duty liquefied natural gas chilled refrigerated vehicle is shown here in the figure. Okay, you can see that it has that thing. Number one, that is the LNG tank, that liquefied natural gas tank is provided. It is provided with valve boxes. It's called energy recovery heat exchanger. That is the gas from this. It goes through this energy recovery heat exchanger. Then there are induced draft fan. This draft fan helps. That is the moving that blowing this cold air into the vehicle. Okay. Then superheater, engine or refrigerated vehicle body. So this is the schematic of the body. Properties of the liquefied natural gas include it is composed of more than 98% methane. Volume of LNG is about 600 times smaller than its volume in gaseous form. Its temperature is generally minus 140 degrees Celsius to minus 120 degrees Celsius. Operating pressure is 5 to 8 bar and enthalpy is 900 kilojoule per kg. In general, the temperature control system which are used in these refurbishments etc., that is the maybe mechanical refrigeration, that is most widely used method for temperature control. Okay. And this operates on the vapor compression refrigeration system, which is commonly known as VCRS, and that is shown here in this figure. A schematic of the vapor compression refrigeration cycle is shown. It has different components, like it is provided with the evaporator, which allows the evaporation of the refrigerant by absorbing thermal energy from the environment to be cooled. So, it provides this evaporator, that cooling effect. Then there is a compressor provided with a compressor, and what it does, the job of the compressor is to compress the refrigerant from the minimum pressure of the cycle, that is evaporator, to the maximum pressure, and it compresses and then sends it to the condenser, okay, by absorbing mechanical energy from an external source. Condenser allows the condensation of the refrigerant by rejecting thermal energy to the external environment, and there is a expansion device which allows the pressure drop from the condenser level to the evaporator level. So, this is the different components of the mechanical vapor compression refrigeration cycle system. Okay. That there is the other system which can be used for the cryogenic system. Cryogenic system may be direct or indirect system. In the direct injection system, which you can see here, that there is a direct injection of cryogenic fluid refrigerated compartment in refrigerated compartment, where it evaporates absorbing thermal energy, okay, and then released into the external environment during the door opening. So, there is a decreased O2 concentration in the compartment, and it is more efficient, and it quickly cools the commodity. Okay. In the indirect system, as you can see here in the other figure, second schematic diagram, that cryogenic gas is expended in a heat exchanger. Here is a heat exchanger provided, okay, and in the heat exchanger, it absorbs thermal energy from the recirculated indoor air. The gas is then dispersed into the atmosphere. So, cold air is circulated in the compartment. It avoids problem of reduced oxygen concentration, and it comparatively takes more time in cooling down in comparison to the direct cooling system, direct injecting system. Let us see, I will tell you a little bit about the calculation of the required cooling capacity. How can we calculate that? The refrigeration system must be capable of removing the all heat entering the vehicle from outside, all heat generated within the vehicle, that is you have placed the commodity. So, that is the respiration low heat etc. generated, or the field heat etc. which coming if it is not properly cooled etc. So, some heat will come from outside, or any heat contained in the vehicle itself. So, the vehicle should be refrigeration system should be able to take care of all these things, remove all this heat. So, to calculate total heat capacity or total cooling capacity Q total of the vehicle can be calculated from, that is Q total is equal to Qi plus Qe plus Qres. Qi is the internal heat load, Qe is the external heat load, and Qres is the residual heat load. Internal heat load Qi includes, as I told you, respiratory heat, that is Qr generated by the produce, and it depends upon the type of the commodity, its loading pattern, it less than, and it is generally less than the normal at freezing temperatures. Okay. Then any field heat, that is the Qf, that remains within the product, and the field heat Qf depends on the product mass M in kg, specific heat Cp, and difference between the initial and desired temperature, that is delta T. So, you can have that is Qi, means that internal heat load will be equal to Qr plus Qf, and Qf is mCp delta T. So, the Qi will be Qr plus mCp delta T. So, using this equation one can calculate the internal heat load. Then external heat load. External heat load Qe, that is, it is heat conducted through the floor, walls and ceilings of a transport vehicle due to temperature difference between the inside and outside air. Solar radiation will increase the temperature of outside if the vehicle is moving inside open air and during summer season, etc. So, this solar radiation will increase the inside the temperature if it is trailer body is exposed to the sun. Then infiltration or heat from warm air entering through small holes, cracks, drainage holes, etc., broken door seals, and also when the doors are opened during the journey, etc. So, in that process also some heat may enter inside the vehicle. Okay. So, that is the external heat Qe, and residual heat load Qres, it is the heat from the air inside the trailer and heat in the insulation and inner lining of the trailer. So, this Qe, external heat load Qe is equal to again U A delta T multiplied by small t. Q is the external heat, U is the overall heat transfer coefficient, A is the surface area through which heat is leaked inside the container, delta T is the temperature difference between inside and outside of the container, and T, small t, is the time of exposure. So, using these parameters, these known values, okay, one can calculate the external heat. Now, you have calculated internal heat load, external heat load, you know the residual heat load. So, one can calculate the cooling, total cooling capacity. Now, let us discuss some of the air commonly used air circulation system in the vehicles, like one may be top air delivery system, which is the most widely used in mechanically refrigerated semi-trailers and rail cars. In this system, as you can see here in the figure, the refrigeration unit is in front of the vehicle. It blows cold air along the ceiling. You can see, blows the cold air along the ceiling. The cold air circulates above the cargo, okay, from the front to the rear of the vehicle. So, a typical top air delivery system is compressed of an air delivery duct along the ceiling. It is horizontal flow duct and a return air bulkhead. Bottom air delivery system, again same you can see here in this figure. In this system, the most air movement is vertical, upward. Okay. The refrigeration system blows cold air in the T-beam floor of the container. This air flows from the front to rear of the vehicle and is forced upward through the cargo. When the air reaches the ceiling of the container, it flows from the rear to the front and returns to the refrigeration unit through the bulkhead openings. Loading pattern should be such that entire floor is covered to force air up and through the cargo. So, the loading pattern should encourage the proper, it should be proper. Okay. Any uncovered floor space, like for example, between pallets, the last pallet and the rear doors, etc., it must be filled with empty boxes, blocks or insulation to prevent cold air from short circuiting, to have a better efficiency of the system. Okay. Now, see the preparation for loading, that is in the loading adequacy of the equipment, that like refrigeration system should have sufficient refrigeration capacity to maintain proper temperature of the intended product load. Cleaning and sanitation that is of the vehicle, etc. Before it is loaded, the vehicle should be inspected, that is, it is cleaned, it is sanitized, because it prevents the bacterial contamination, chemical and other contamination of the food product loads. That is, if initially if you have some transported through odorous materials, etc., so some odors may be there. If we load it a new fresh commodity before cleaning, properly sanitizing it, then there may be some contamination of the flavor. Okay. Vehicle maintenance is very important. It improves vehicle ability to maintain desired product temperature during transit, and pre-cooling or pre-warming of the vehicle. It needs to attain desired transit temperature for the produce. It reduces chances of overloading the refrigeration system. Okay. So, for preparing the loading, as I told you, the condition of the inside of a refrigerated trailer affects the ability to maintain the desired transport temperature during the transit. So, handlers before loading, they should inspect the trailer, okay, and check for the various features like that air delivery chute, whether it is intact or not, door seal if it is damaged or not, that is if there is any side door seal, whether it is tight or not, or door damage, okay, wall damage, front bulkhead installed or not properly, floor drains, whether it is openings, etc., it is properly cleaned or not, floor should be cleaned. So, all these things, for all these things, the vehicle should be properly checked, and it should be ensured that there is no damage, there is no leakage, it should be everything clean, then only the material should be loaded. So, loading consideration, that is the type of air delivery, top air delivery or bottom air delivery, type of shipping containers, like stacking based on the type of containers such as wooden boxes, corrugated fiberboard boxes, wooden baskets, etc., or type of the produce, whether it is a frozen produce or non-frozen produce, because the type of food decides the refrigeration capacity, cooling capacity. Then mixed load, whether shipment of 2 or more produce together, desired. So, desired transit temperature and relative humidity should be within the reasonably close range. That is, if you are multiple product if being transported in the same vehicle. So, all those requirement of the cooling storage, etc., cooling temperature of all those commodities should be at least closer to each other. Okay. And then length of the transit period, how long it will take in the transit transportation, 1 day, 2 day, 1 week, 2 week, 1 month, etc. This because it affects the loading decision, that is for the particularly, for example, for same produce, denser loading pattern can be adopted for overnight shipment. Okay. But if it is having a long thing, that is 2 weeks, etc., denser loading pattern can be avoided, should be avoided. Okay. Then these are the loading pattern, that is hand stock loads. You can see here in the figure how it is shown. Produce transported in cartons should be stacked so as to allow adequate air circulation through the load. The figure illustrates crosswise offset loading of the partial telescopic containers on the floor of the truck. Pallets or other supports should be used to keep the cartons out of the direct contact with the floor. Okay. Then use of proper channels, that is the parallel channels, etc. When cartons of various sizes are to be loaded together, the larger and heavier containers should be placed on the bottom of the load. Parallel channels should be left for the air to move through the length of the load. Then pigeonhole pattern, you can see here boxes are stacked in a alternating solid and open layers, and channels are left down both side walls. And this pattern provides channels for proper air circulation, that is air circulation lengthwise through the load, and it allows every box to be in direct contact with the refrigerated air. Then pallets and slip seat loads, the container should be loaded, as you can see here in the figure, should be loaded so that they are away from the side walls and the floor of the transport vehicle in order to minimize the conduction of heat from the outside environment. Okay. The use of pallets keeps the cartons off the door of the floor, while center loading leaves an insulating air space between the pellets load and the outside wall. Okay. Bracing, very important thing, bracing the load. There should be always, it should be to avoid between the last stack of produce and the back of the transport vehicle. The load should be braced to prevent shifting against the rear door during transit. If the load shifts, it can block air circulation, and fallen cartons can present a great danger to the worker who will open the door at the destination market. So, a simple wooden brace can be constructed and installed. As you can see here, different designs of the brace are provided in this figure, that is, this should be installed to prevent damage, any damage to the packet during the transportation. Okay. So, here these are the various factors I have summarized in this table, that is the factors affecting quality of the produce in transportation and the remedial solution, like initial quality, defective or damaged produce more susceptible to disease or physical damage. So, selection of the proper varieties, they should be harvested at optimum maturity. All these things also we discussed in the real class. Then produce temperature, because this temperature influences the metabolism and determine deterioration rate. So, it must be ensured that proper maintain the desired temperature throughout the journey, check refrigeration capacity, etc. Okay. And overcooling should be avoided, otherwise it may cause chilling injury, etc. Then humidity and water loss also, maintain high relative humidity around the produce, reducing water permeability of the produce surface, that is by applying wax to the surface or such other measures. Okay. It should be ensured that humidity is maintained, providing only sufficient air movement to remove heat of respiration, etc. So, these are the various factors. Okay. Then gas composition, again we have discussed is that use of CAMS system will be beneficial, and any physical injuries should be avoided, that is the effect of physical injury, rubbing, compression, etc. It results to the quality loss, damaged tissue decay more rapidly, and this decay may spread and ruin the other produce, etc. So, use of proper packaging material, stack or load produce carefully in vehicle, secure the cargo within the vehicle by using aluminum or wood load locks, fiber wood, honeycomb fillers, wood blocking and mailing strips, or inflatable craft paper airbags, etc. Okay. And here that mixed load and transport conditions we have provided, that is the different groups, that is the similar material, that is which required almost similar temperature, etc. Temperature and relativity during transportation, like in group 1, apple, apricot, berries, etc., fig, grapes, peaches, their temperature may be required to 0 to 1.5 degrees Celsius and 90 to 95% humidity. And the atmosphere that is normally used on berries and cherries only 10 to 20% CO2, for other, that is the normal atmosphere may do. So, never in contact with the commodity, that is ice should not come in contact with the commodity. Similarly, in the group 2, it is avocado, banana, olive, fresh papaya, pineapple, etc., tomato, green tomato, pink watermelon, etc. that they require temperature around 13 to 18 degrees Celsius, relative humidity 85 to 95. And here the ice should never be in contact with the commodity during the transport. In group 3, cranberries, lemon, lychee, oranges, etc., they require temperature 2.5 to 5 degree and 90 to 95% humidity. Group 4 is the beans, snap, lychee, okra, peppers, etc. Okay, and they require the temperature 4.5 to 7.5 and relative humidity around 95%. In group 5, cucumber, eggplant, ginger, grapefruits, potatoes, etc. they need temperature 4.4 to 113 degree Celsius and relative humidity 85 to 90%. In group 6A is the artichokes, asparagus, beet, red carrots, etc. 0.0 to 1.1 and relative humidity 95 to 100. So, I am giving this data just for information that these are the, even when there is a need to transport multiple commodity in the same vehicle, so they can be selected in this, they can be grouped in this. Similarly, group 6B is the broccoli, Brussels sprouts, cabbage, cauliflower, etc., turnip, radish. Okay. They again temperature 0 to 1.1 and relative humidity 95 to 100%, and here this ice contact is acceptable for all commodities. Group 7 may be ginger, potato, sweet potato, which require higher temperature comparatively, maybe 13 to 18 degrees Celsius, relative humidity 85 to 90%, and here again it should never be in contact with ice, etc. Particularly in the cryogenic vehicles, etc., if it is used, it should be taken care that there is no freezing, etc., of the produce inside. The temperature should be maintained properly. In the group 8, it is the garlic, onion, 0 to 1.5 degree, relative humidity required is 65 to 75%. Okay. So, now I will like to summarize this lecture, that is the proper and careful handling of fruits and vegetables is essential at every stage to reduce post-harvest losses and maintain quality. Temperature control and air circulation are important aspects of the transportation of fruits and vegetables. Irrespective of the mode of the transport, careful loading preparation and pattern should be used, and it eases the smooth delivery of the produce at any level of supply chain should be ensured, and different combinations of produce can be transported in the same vehicle, provided as I have given you in different groups, that is if the temperature and relative humidity are reasonably closer. These are the references that I have used in this lecture. With this, thank you very much for your patience hearing.